So we're going to be solving log equations with the product and quotient rules. So just to recall here, if I have a ln of a times b, this is the ln of a plus the ln of b. And the quotient rule says if I have the ln of a divided by b, this is the ln of a minus the ln of b, okay? So here I've got a difference, so that means I'm gonna divide. The game plan here is to try to get your logs condensed as much as possible before you start trying to convert, okay? So if I can condense this to one log, the better. So this is x in the numerator, that's the positive one, and the negative one goes in the denominator, x minus 1 here, equals 1. Now how do I get rid of a log, an ln? Remember ln is log base e, right? So how do I get rid of something that has a log base e? Well, I raise both sides to the same base, right? That cancels. I get x over x minus 1 equals e to the 1. Now, I've got this fraction here. I want to solve for x. So what I'm going to do is I'm going to multiply both sides by x minus 1. Okay, so those cancel, and I get x equals e x minus e. Now I'm trying to get x by itself, okay? So what do? Well, let's subtract x. I want to get my x's together. Okay. Now I'm trying to get x by itself, right? I have an x here and an x here. What can I do? I can factor out GCF, and I have 1 minus e here times x. And now how do I get x by itself? Divide by 1 minus e. So 1 minus e. So my answer, x is equal to negative e over 1 minus e. Or, another answer, if you factored a negative out of this, you could have a negative here. And then you could factor a negative 1 out of here, and that would be negative 1 plus e. And so those negative 1s cancel, and you get e over e minus 1. So either one of these will work. To get the approximate value, just type it in your calculator. So e over e minus 1. So I'm going to do the second and then the divide button. E divided by, what was it? It was e minus 1. So parentheses, e, and then minus 1, close parentheses, enter. So that's 1.582. 1.582 right there. Okay. Once again, like this, this technique is, once you do a little bit of practice, you get pretty good at it. But some people, it's like, man, this is like really hard to solve this type of problem. So if you're having trouble with this, you can convert e to a decimal. So if we convert e to a decimal, so e, let's do 4 decimals. That's 2.7183. Let's do 5 just so we can be sure. 71828. So 71828. So that's e, approximately 5 decimals here. So I want to take this and I'm going to convert it. So I have x equals 2.71828 x minus 2.71828. Okay, to solve for x, I could subtract x here, subtract x here. So I have 1.71828x. When I add 2.71828 here and add it over here, so that's 2.71828. And then I divide by this, and I hope that this is going to be the desired accuracy. Okay, so let's see. So what do we have? 2.718 1.72828 divided by 1.71828, enter. 1.582. 1.582. Okay, so it worked for us that time. All right, so if you're more comfortable using the decimals, if you got to do what you got to do, right? So you can convert it. Just type it in your calculator, write out 5 decimals, and then that should be good enough to get your 3 decimal approximation. Okay, let's try another one. Log base 5 of x equals log base 5 of 2x plus 3 minus log base 5 of 2x minus 3. Okay, combine your logs. When you see a difference, that's division. That's log 5, 2x plus 3 over 2x minus 3. This is equal to log base 5 of x. How do I get rid of a log base 5? I 5 it on both sides. Okay. These cancel, and I have what? X equals 2x plus 3 over 2x minus 3. How do I start solving for x? Multiply both sides by 2x minus 3. Okay, these cancel. So what am I left with? Distribute the x. I have 2x squared minus 3x equals 2x plus 3. Subtract 2x, subtract 3, subtract 2x, subtract 3. I get 2x squared minus 5x minus 3 equal to 0. Oh man, does this even work? Well, let's see here. 3 terms might need to use the AC method. AC method. All right, multiply the first and the last, the A and the C term. What do I get? I get negative 3 and 2 gives me negative 6, and it needs to add to 5. So 6 times 1, negative 6 plus 1 gets me negative 5. All right, good. So that works. So this tells me how to split it up. So I have a minus 6x, but I have a plus 1x, minus 3 equal to 0. I'm going to factor by grouping now, make sure a plus is in the middle. And so I can factor a 2x out of the first, and I have x minus 3. And then I can't factor anything out of here, but I can always pull that 1 out, and I have x minus 3. So what's left? So the x minus 3 here, factor comes out of both of those. And what am I left with for the second part? I'm left with a 2x plus 1 equal to 0. And so I set each piece equal to 0. And I solve for x. X equals 3, or x equals subtract 1, divide by 2, that's negative 1/2. Okay. Now, something you have to be careful about when you're combining logs, you're making the assumption that each piece that you're putting together is positive. That could be dangerous. So what do you have to do? You have to plug this back into the original equation to see if it works or not. So we got to go back to the original and see if it works for the original. So go back to the original, plug in the values, see if they work. So what do you have? You got log base 5 of 3 equals log base 5 of 2 times 3 plus 3 minus log base 5 of 2 times 3 minus 3. So 2 times 3 is 6 plus 1, that's 9. Log 5, 9. Minus log 5 of, 2 times 3 is 6 minus 3 is 3. So what do I do? Log properties, that's log 5 of 9 over 3, which is log 5 of 3. That's what I wanted. Okay, so this one works. So that's a good answer. That works. Let's try negative 1/2. Okay, if I plug a negative 1/2 in, to my equation. I have log 5 of negative 1/2 equals log, oh, I don't even have to keep going. Why do I not even have to keep going here? Because what do I know? Right off the bat, I can't evaluate a negative number in my log here. This whole thing is negative. So, no, not a real number, okay? It's like taking the square root of a negative number. Can't do it. Can't take the log of a negative number, okay? That's a no-no, all right? Don't do that, okay? So we know right now that this is not a solution. So you would just cross that out or not box it up. So my only answer for this problem is x equal to 3. Okay? So always be careful. Check your answers when you're combining or expanding or whatever. All right. We'll do one more example and then we'll be done with these. We're kind of doing overkill, but I just want to make sure you guys are good since I'm not there to help you out. Okay, so log x minus 16 plus log x minus 1 equals log of 100. Now, if there's no number down here, what's it understood to be? It's understood to be a base 10, right? So that's a common log. So when I have addition, what do? I multiply. That's log of what? X minus 16 times x minus 1, which is equal to log of 100. Okay. Now to get rid of log of 100, I raise both sides to the 10, right? So the 10 here. So that gets me 100 equals this, x minus 16 times x minus 1. If I multiply it out, FOIL, first, outer, inner, last, okay, double distribute, I get x squared minus x minus 16x plus 16 equals 100. Combine, move everything over, I get x squared, and then I have minus 17x, and then minus 84. This is a trinomial, so that's a trinomial there. So I think it can factor 84 factors. So I wanted to multiply to negative 84 and add to negative 17. Okay, 21 and 4 gets me 84, and that looks like, yeah, there we go. Since it's a 1 in front, I don't have to do the AC method. I can just write it out. This is x minus 21 times x plus 4, okay, equal to 0. So I plug in, I get x, set that equal to 0, and set this equal to 0. And I solve for x. X is 21, or x is negative 4. So I need to check with the original. Okay, so the original equation right here, you know, does the original equation jive with our solutions? So when I plug in 21, log of 21 minus 16 plus log of 21 minus 1 equals log of 100. Well, log of 21 minus 16, that's log 5. And then 21 minus 1, that's log 20. Okay, this is equal to log 5 times 20, which is equal to log 100. So that works. So this one's an answer, good. Now let's try negative 4. I plug in log of negative 4 minus 16 plus log negative 4 minus 1. Oh, well, do I even have to keep going? What's happening here? Now all of a sudden I've got log of negative 20. That's not real. You can't have a negative inside here. It blows up. So what do I know? This is not a real solution. Okay? So There's the work all together for that last problem there. All right, guys, good luck. Be careful. Check your solutions because some of them might be extraneous solutions. Like this -4 here was an extraneous solution. Okay, it's no good.